Today I want to make a filtration / regulation station for the top of my workbench. Reason for this is my compressor has two outputs. One of them has a regulator on it in case I want to change it, but it's a little bit coarse, especially if you want to try and do some lighter stuff like airbrushing. To change this down to sort of 1 or 2 bar is quite difficult. Also, I've got the regulated output set up to my general tool air hose. I wanted to connect up the full outlet up to the top of the worktop. So what I'm after is to get the pressure gauge so I can read the tank pressure from the top of the workbench rather than having to put my head underneath here, and also get some finer regulation for airbrush use and stuff like that. So that's what I'm going to do. Follow me. Parts for this sort of job can add up quite quickly, so think carefully about what your requirements are. Draw it out on a board if you have to. So I first decided what the bigger components were going to be for my valves and regulation. So the rough layout I wanted was to have an incoming hose, so got just a hose connector. I wanted to have a pressure gauge, so that would show me what the tank pressure was in the main compressor. I wanted an isolation valve, so I can shut off the regulation station if needed. So this is a 1/4 turn full flow ball valve. Then my filter regulator. So I bought these from AliExpress. They look exactly the same as the SMC range, which are also made in China, so it's possible they're the exact same units. This one's got a copper filter and this one's got a fibre filter. I probably don't really need to, but I think the copper filter is slightly finer than the fibre filter. So I'll put that one downstream of the main regulator. Possibly against best practice, as you'd normally have a filter to protect your regulator, but I'm sure this fibre filter works before the regulating valve inside here anyway, and I would have thought you'd be fine with just one of them, but I've got 2 anyway just to be on the safe side. I then wanted dual output, so 2 quick connectors. So you've probably noticed here that this has got a compression fitting on it, and these ones just have a standard, I think that's a 1/4 inch BSP fitting. These ones have got 3/8 BSP. Some of them are tapered, some of them are parallel, so that's a little bit of a pain really. So once you've got it all laid out like this, work out how you're going to connect them all together. Before you start cutting copper or soldering things, I would just screw together all your fittings, not tightly, but just make sure they all fit together and it's all laid out as you'd hope. I've done that with mine. My hose is going to be coming in through to the adapter down to 15mm pipe. It's going to go up to this elbow, through this T-piece, pressurize that gauge, through the valve, through another adapter, through these ones, back to copper pipe, and then back to quick couplings. So I only need a short little bit of copper pipe between each of these, and then I should be good to go. Once you've got all your components laid out and ready to assemble, just a case of working through them all, making sure they're all gas tight and putting it all together. I'm going to start with the copper joints. So I'm going to use these solder ring fittings. You might use the normal ones in where you have to add your own solder. These ones have got that already built in, so your stubs of copper need to look something like that. So you need to emery cloth that, just a 120 grit emery cloth, clean that up, and they need to just be inserted all the way into there. One thing or 2 things not to do. The first one is don't try and do just one end at a time like I did, well, unless you're very careful, because the copper on the other end is likely to melt, and then you're probably not going to be able to get that bit in, so get it all connected up and do them all at the same time would be my recommendation, so don't do that. The other thing not to do is use soft jaws with these sort of plastic. I thought they were some sort of a silicone, but they've melted, so just use the normal vice. I was trying to not scratch the pipes, but as soon as you see the solder start to come out of the pipe, that means that fitting's done, so that should hopefully be gas tight. I'll work through the rest of these and move on to the compression fittings. When you come to do the threaded fittings, I usually use PTFE tape no matter what fitting I'm doing. So this one is a 1/2 inch BSP, and you can see how easy that's going in and out all the way to the bottom. So that's a parallel thread. You can also see by just looking at it, whereas this one is a tapered thread, so that goes into a parallel hole, and you'll get to a certain point and you won't be able to turn it much anymore, so that will probably give you a bit of a tighter seal. I don't know why they're not all tapered into parallel, because you don't get a proper face seal on these, but either way, whack some PTFE on it and tighten those up. If you've got it available, I find it a lot easier to tighten these inside of a vise rather than want to sort of set out onto the board, because you could find yourself wrenching your equipment off wherever you've mounted it to. So I'm going to do as many of these as possible just in the vise. Once you've done your soldered fittings, it's not a bad idea to just blow it through with some compressed air, if you've got it. So that'll just get all of the dust out and solder and whatever else that you've got left in there, just so you don't block up your filters straight away or go into your gauge and other sensitive equipment. So when you get to your compression joints, they generally come looking like that, and they have an olive inside of it. They usually come with a brass one, and you can buy copper ones as well. I don't actually know which one's best, so if you've got any tips for me, leave a comment and let me know. I'm going to use copper today because that's a bit softer, and that'll hopefully mean I can squeeze it up a bit better. Might be completely the wrong logic though, not sure. So threaded ring over the pipe, then put your olive on, and then screw it up at the top, and that'll compress down. I think you're meant to use a new olive each time, so try to just do this fitting once. Need to put a 24mm spanner on my shopping list. I hate adjustable spanners. Okay, that's looking pretty good. I was a bit nervous about this joint in the middle here, because if I'd have tightened up fully, these wouldn't be in orientation, so I'm hoping that that one's going to hold okay. Same with these couplings as well, because I'm not particularly used to the compression fittings. So what I'm going to do is give it a little pressure test now. If you're nervous about this, you might want to wear some goggles or something. I'll connect the hose up to the compressor. I'll go to initially the regulated supply of the compressor, just so I don't whack 8 bar through it straight away. Slowly take it up, make sure everything works and there's no leaks coming out of it, and then mount it up to the board. Not a very good start. So it looks like there's a minimum length of thread you might need to make this hose end work. I'll give it a try, and I'll put this quick coupling on it, see what happens. I can always change it later. I know this is the wrong way around, so sorry about that. Pressure gauge seems to be working. Can't hear any other leaks. Let's slowly open this up. If you spray a bit of fairy liquid or wash on it, you'll see where the bubbles are coming from. You can see it's coming from here. Just nip that up. Okay, that's now airtight. So it looks like it's the 1/2 inch to 1/4 inch fittings which are leaking a bit. I'll try and give it a little nip up, depressurise it first, and if not I might need some new fittings. That all looks good. Let's mount it up onto the wall plate. So just offering it up where I want it to be now. Just little pipe clamps. I'll see how this goes for the next few weeks. I might put an additional bracket onto here, something like that, just to stop that from pushing. It feels fairly solid. It's probably alright actually, but I'll see how it goes anyway. I've been using it for a few months now. I'm pretty pleased with what it does. Looking back, there'd be a couple of recommendations I would have. Firstly, these threaded couplings aren't particularly good, so I would use end feed couplings wherever possible, as you see in the other video. I couldn't find these at the time. If I had to remake that, I would solder as many as possible, because these were a bit of a pain to get them to fit. I use PTFE along with Loctite, and that's now been airtight now for quite a few months, so it should be fine. Also, where your quick connectors are, I would make sure that's nice and solid and mounted to the back plate, because when you start putting the plugs in and out of it, you can put a little bit of strain onto the pipes, and that can disjoint things if you're not careful. So I would put your final bracket as close to the quick coupling as possible. And also, as you probably noticed halfway through, the style changed, so I changed to these higher quality high flow couplings. Check out the optimisation video to hear about why. I'll probably also make this a little bit bigger because it's a bit hard to see from a distance. I'll probably buy a larger gauge for that at some point, like a 4-inch gauge or something, so I can see the tank pressure from anywhere in the garage. So as suspected, for any use with an airbrush, this sort of regulator is pretty much mandatory. You can see that at the moment it's around about 0.2 bar, 20 to 30 psi, and you'd never get that from one of those coarse regulators you get mounted onto a compressor. So there you go. If you want a permanent air regulation station, I'd recommend doing something a bit like this, as it makes your life a lot easier, whatever you want to be using, whether it's tools or airbrushes or spray guns and things like that. It's always handy to have something like this.